The labs in this course are a little unique. You're going to be doing labs that all deal with weather maps. There's a bunch of weather maps. So I thought I would give you a little bit of a rundown on a few here, especially the ones you're going to cover in the first few weeks of the course here. Basically, what I'm looking at right now in front of my face is a surface weather map for today, this Tuesday afternoon. All right, so H's indicate high pressure, means the pressure is higher there. L's indicate low pressure. You have learned this week that around high pressure, winds flow clockwise, and around low pressure, they flow counterclockwise. I want you to notice we actually have wind barbs on these station symbols here. So we'll be able to look at them in some more detail here. But there's a front, cold front here and all. Dividing in air mass. Temperatures are in the 50s and 60s back here and in the 80s out ahead of this. Quite a temperature contrast between that front. So let's zoom in and look at what we're really looking at on a surface weather map. So this map, when it comes up, is going to high resolution station plots. That's what a surface map is. Think about it. If you were in Beckley or Elkins, West Virginia, or Charleston, West Virginia, and every hour the ASOS at the airport takes an observation. That observation consists of pressure, cloud cover, visibility, precipitation type, wind direction and speed, the dew point, which is a measure of moisture, and the temperature. Wow, that's a lot of information, isn't it? We need that information to plot on a weather map so we know what is happening. If you walk outside, you're interested in the temperature, I bet. Or if you walked outside, maybe you'd want to know if it's raining or not, or cloudy. So maybe you don't want to be blown away. Maybe you have some event you're planning that, oh, we don't want too much wind today. All of those things are plotted on this weather map. So let it zoom in here to Beckley, West Virginia. Here is Beckley. To the upper left is temperature, 82 degrees at this moment in time. If you look to the upper left of the station plot on any of these, you see the temperature. That circle right there is right over, supposedly over Beckley. Notice it's nothing in it. Not a single cloud in the sky today. The more that station symbol's colored in, the more clouds you have. So you look at what percentage of the clouds of the station symbols covered in with dark. That would be your clouds. For example, up here in Ohio, you have a little bit of clouds, just a few. Maybe a mostly sunny day, but a few clouds around. Beckley, right now, sunny. Off to the lower left is dew point. Dew point is a measure of moisture. We're going to talk a lot more about dew point in a few weeks, so we'll not get into it. But just say the higher it is, the more moisture is in the air. How about that? So we have 61 degree dew point. Again, you can look around and say, oh, there's 66. Oh, here's 55 or 64. Here's a 72 dew point. 72 is lots of moisture in the air, actually. So these are different measures of moisture. To the upper right is pressure. All right. One thing you're going to learn about pressure is we put 3 digits, which means the last digit is the 10th. So, always, since pressure is basically 1,000 millibars on average, there's got to be 4 and a 5th digit would be the tenths. So, that means you need 2 digits in front here of this. So 1021.2 is the actual station pressure, sea level pressure actually. So that means that 1021.2, if you're plotting a map, would be what you got from ASOS or whatever. So that is your station pressure. Anywhere you look on this map, here's 188 would be 1018.8, lower than up here. And if you have a very strong low pressure system, the pressure may be below 1,000 millibars. So if you see this number and say it's 959, you would put a 9 in front of it. It would be 995, 0.9. So that would be the station pressure. That's all you're doing here. If that number is basically greater than 500, you're putting a 9 in front of it. If it's less than 500, you're probably putting a 10 in front of it. Now, the final thing I want you to be able to read on this map, we don't have any precipitation. Precipitation would be plotted off to the left-hand side, is this barb. That is a wind direction and a wind speed. All right. Think about a compass. If I had a compass centered right here, this would be due north. This would be due south. If I have a wind coming in from this direction, it's coming in from the northwest. Meteorologists look at where the wind is coming from. So this is a northwest wind. There's a very tiny barb on that. See this one right here, you can see better. That's 5 knots. So what we have here is 5 knots of wind out of the northwest. Not a lot of wind, really. So if I was looking around for a little stronger wind than that, there's not a lot today, really, in this area. Here would be a longer barb, 10 knots. So all you're doing when you're calculating wind speed, seeing how many long barbs there are, and how many short barbs there are to get a wind speed. So if you have 4 long barbs and 1 short, you have 45 knots of wind. Pretty strong wind. If you just had 4 long bars, you had 40 knots. Now, if you have a flag or a pennant, that's a 50-knot symbol. So then you just add that on to this. And notice, if you look at the circle here, it might be Toledo, Ohio. Notice the winds are coming out of the southwest. That's the direction they're coming in. So now we have covered how to read a weather map. We've looked at some fronts and some lows. You can actually see on the high pressure here, high is centered over West Virginia. Southwest winds to the west of it. East winds here, or northeast. Clockwise flow. Let's look in the vertical. So in the vertical, I want you to think about the atmosphere as 3-dimensional. So here we have the 3rd dimension, vertical. All we have done here is there's a balloon that is released, and this is Dulles Airport, every day, twice a day. Sometimes it's 4 times a day, depending on the weather. So that balloon went up, and as it was going up, an instrument recorded the temperature, the dew point, the pressure. And since you can calculate how fast the balloon is going up by how much helium, in this case, is in it, we know exactly where in the atmosphere that pressure was. So we had an altitude as well. And all this map did was plot the temperature, and they come every second, so you can see there's a lot of temperatures plotted up here, and a lot of dew points plotted here. Where they're close together, there might be clouds around. Especially when they're real close like this, there probably is some clouds. The pressure is off to the left. Temperature readings are down here, and they're straight up. So when you look and the temperature was at 700 millibars, well, I go over here. There's my temperature. Bring it straight down. It's probably around 8 degrees Celsius. I want to know what it is at 500 millibars. I go up here, right about there. I come down. It's about -8, -9 Celsius. So you can see I can tell the temperature. If I ask you for the dew point, same exact thing. You bring it right straight down. Finally, since we can have a balloon going up and it has a GPS on it, we can track that balloon. So we know where it's at. The only way it's changing from going straight up is if the wind's blowing it. So that way we can calculate the wind as well. So we have that right here. We already learned the bars, big ones 10 knots, little ones 5 knots. And we learned that this would be a northwest wind because the station symbol is down here. This would be a north wind. You can see the winds change with height. They're actually quite light in the lower levels, pick up as you go up, much stronger as you get further up. So that is a vertical profile of the atmosphere. Now you've seen that. One last thing I wanted to show you, because you're going to see it in a few weeks, is a meteogram. On this meteogram, every hour is plotted a temperature. Left-hand side, you'll see 40, 50, 60, 70, 80, 100. Those are dew point and temperatures. Look off to the right-hand side, you see 25, 50, relative humidity. So lines are labeled. The blue is temperature, green's relative humidity, darker color down at the bottom is dew point. All you can see along the bottom are times. So, for example, where you see the date, that is midnight. So 25th of August is midnight. Where it's 26th of midnight, that's another midnight. You can see from that, go straight up on any of these lines and you'll have the temperature, dew point, relative humidity. You're going to get similar charts like this in a couple weeks on your when we're going to be studying some more about temperatures. So get a little feel for it now. If you have any questions about labs, I'm here to help. So let me know.